Let's discuss about degrees of freedom. What are the degrees of freedom? We use the concept of degrees of freedom in analyzing a structural member. This is related to deformation of a point of a structural member. Before going to explain what are the degrees of freedoms, let's talk about motion of an object, because the degrees of the concept of degrees of freedom is very much related to the concept of motion of an object and how we can divide different components of a motion. Let's discuss with an example of a Rubik's cube. Now you have a Rubik's cube here. Suppose you have thrown the cube to some distance away. Now it turned and twisted and dropped, and after traveling some distance it gets this new position. Now if you notice, you can see that the points on the original position of the Rubik's cube have traveled different amounts of distance. All the points didn't actually travel the same amount of distance. However, we can assume a motion of the Rubik's cube where the Rubik's cube can move with all its points traveling same distance like this. Now you see the final position and this intermediate position. Now they are not same, but if we just rotate this intermediate position about a vertical axis, we can get exactly the final position. So the final position of the motion of the Rubik's cube can have actually two components. We can assume that all the points traveling same amount of distance and then rotating the cube about an axis, about a center of rotation. So any motion can be divided into two components. One is which we call linear motion or translation, where all the points of an object travel the same distance, and second, a rotation, where the points of the object rotates about some center of rotation, and combining these two we can get different positions. Similarly, now we get back to the example of a structural member. Here suppose we have a point. Just talk about a point on the beam. Let's zoom in and see the point. We can assume that the point is something similar to the Rubik's cube. It has got some finite dimensions. So if we zoom in, and the point is somewhat like this within the body of the structure. Now when the beam is subjected to some forces, it gets deformed along with the point. The point, due to the deformation of the beam, the point moves. The point, just like the Rubik's cube, it gets a new position, and this movement or deformation has two components. One is linear deformation, where when the beam goes down, the point, just like the Rubik's cube, goes downwards, and due to the bending of the beam, it can also get rotated. So any node or point on a beam has 2 degrees of freedom. One is vertical translation, another is rotation. So this is for a beam, for a three-dimensional object, for other kinds of structural members. Now if we go back to the example of the Rubik's Cube, we can think of linear motions in 3 directions, x, y and z. Let's see the axis, and it can go along x, y and z. Actually it can go in any direction. We can resolve that motion into the components along x, y and z. So it can move upward, rightward or leftward, and frontward or backward. So it can have 3 translations along x, y and z. Similarly, it can rotate about x-axis, for example like this, or about y-axis like this, or about z-axis. So in general, in a 3-dimensional object, we can have translations in along 3 coordinates axis, and we can have rotations about 3 coordinate axis. So in general, in a 3-dimensional object, we can have 6 degrees of freedom. But depending on the type of structural member, sometimes we consider some degrees of freedom and sometimes we ignore some other degrees of freedom. That's why for beam problem we have only in one node we have only 2 degrees of freedom. We do not consider deformation frontward or backward, rightward or leftward. We only think of deformation only vertically upward and downward. So 1 degree of freedom, and we think of rotation along about an axis which is perpendicular to the beam. So that's all about degrees of freedom. Thank you.